right, we should get started because we have quite a bit of slides to cover, and I have been explicitly advertising this session, so hopefully we will complete it. So I'm Susie Vishwanathan, product manager at the storage team at VMware, particularly driving virtual volumes. And this gentleman here needs no introduction. He's been, he used to be a Hollywood star, now he's VMware star. So I'm guessing most of you are here to watch him speak as well. So we'll do justice, and I'll speak a little bit and then hand it over to Rawlinson. And then between us both, we do have a guest speaker. And it's going to be one of the storage array vendors, and I'm going to introduce him when we get to that stage, and you'll get to see a little bit of what they have done for virtual volumes as well. Okay, so let's get started. All right, so this is going to be a technical discussion. As you can see, the agenda is quite heavy. We are trying to go technically deep, however, we cannot cover all points. So if you do have questions, ask us at the Q&A session or meet us after the session, and we'll be glad to explain it. All right, so talking about software-defined data center, we're always going to be starting with this. Virtual volumes is a huge piece in the software-defined data center, okay? We are definitely focusing on every aspect of, every aspect of storage. Our intent here is, regardless of what storage you have, okay, we want vSphere to provide the storage platform and the services on top of it. And as you're well aware, Rawlinson has been talking about virtual SAN throughout this VMworld as well, and that addresses exactly this portion here, okay? And we are not stopping at that. We are focusing on enriching the external SAN NAS array as well. And that's exactly what virtual volumes is all about. So let's focus on that one particular angle and talk about what are some of the challenges that virtual volumes is going to address. There's a little bit, quite a few contents here, but some of the key things that you're going to stand out in these slides are these LUNS here, and then complex provisioning cycles, and then over provisioning and bookkeeping. So some of the issues that you have all reported on is the LUN size, the number of LUNs, okay? It is always rigid. You have only 256 LUNs. Each LUN used to have 2 terabytes in size. It is now 64 terabytes, but it does have an upper limit. So these are all issues encountered by you. And you have always been wondering how you can overcome those issues. What can vSphere do for you to no longer have those issues no longer give those issues in your environment? And that is one of the key focus for virtual volumes, and going forwards you'll see how we'll go step by step and see how we are no longer bound by the limits of a LUN and how fine granular we get, okay? We are also going to talk a little bit about these provisioning cycles. We are going to delve deep into storage policy-based management as well, where we are going to allow you to express requirements through policies, okay? And that can be a little bit of a overarching high-level concept right now, but we'll talk in terms of what it means to the array and what it means for the vSphere admin as well, and then we'll stitch all the pieces together. Okay, so with this, let's get started with the virtual volumes concept as well. So the high-level architecture. So the first aspect that you're going to look at is something called as the VASA Provider. So in order to understand this, you have to keep comparing to the current storage paradigm that you're used to today, okay? So today, the entire purpose of a file system is to act as a volume manager, among other several things. And what it also does is creates VMDKs and provisions those VMDKs onto a LUN, okay? That concept is going to go away, all right? we are going to look into what a VASA provider is, what kind of mechanism it actually talks, what is it used for, okay? We are going to talk about that in the next slide. The second aspect that you're going to understand is something called as storage containers. So we definitely have the concept of LUNS and data stores today. Now we are going to no longer need a LUN anymore with the virtual volumes paradigm. Instead, we are going to introduce a concept called a container. We are going to see why you need a container. Okay? We are going to understand how a container is compared to a LUN today. All right? And then we have something called as the virtual volumes itself. You have been hearing virtual volumes, VMworld, so on and so forth. What is it? And what does it represent? And where does it, and where is it stored? So virtual volumes is nothing but your current today VMD case. We are going to see how that is being interpreted. I already said there's no file system. How is the virtual volumes interpreted? How is that going to be created? Who's going to create it? We're going to see in depth about that as well. And then as a example, as a customer pointed out, this little box here called the PE. This is a third paradigm that we are going to talk about in detail, a protocol endpoint. What is a protocol endpoint? What is it used for? How is that connecting with the ESX array and the underlying ESX and the underlying array? Okay, and we are going to talk about storage policy-based management. So I want to pause here a little bit and say that this is all a little too much on the one slide. What we are going to do is take each of these and focus on one different entity, item by item, and then we'll put it all back together, okay? So let's get started. So let's talk about the VASA provider, okay? So to understand this, you got to have a file system today. I already mentioned that. You need a file system which is going to create the VMD case. The VMD case reside in your LUN or your data store. Now, VASA provider here stands for vSphere APIs for storage awareness. If you're a VAAI customer, you're already aware of it. These are nothing but a set of APIs that ESX exports to the underlying array, okay? And we mandate that the underlying array develops their storage firmware for these APIs. So this becomes an out-of-band mechanism is what we internally refer to it. This becomes a communication between the ESX and the array. For example, we would have an API where we could say you snapshot a particular VM that actually transports into an API, and that API is taken by each one of the arrays underneath. It could be any array, by the way. It could be EMC, NetApp, Pure Storage, Nimble, it doesn't matter. Each of them have to mandate to those set of APIs, okay? And that is developed by the software array, okay? It is a software component. So what the array does is they create this, this set of APIs that then talks virtual volumes, and they give it to you, hand it over as a firmware piece. So although all these complexities are there, the way it is going to manifest is simple as a firmware upgrade, or as simple as installing a plugin on top of your array, okay? The second portion to it is, this is how exactly where ESX or the vCenter connects to your underlying array. And we talked about it. There are a certain set of APIs that we mandate, and we talk to the array through those APIs. What do these APIs do? So they are there to do two things. One is ESX uses it to expose fine granular details of the files of a VM. Okay, what is the file of a VM? It's a VMDK. So we will use these APIs to actually have those individual files reside natively on the array. This is a different concept altogether. That's exactly why we are saying we don't really need a file system. because we are using these APIs informing the array that now the files or the individual objects of the VM can now be created on the array. So your VM decays, which are nothing but what we are calling as virtual volumes, now reside on the array. Okay? Now, a single VASA provider can, of course, manage multiple arrays. This is actually a nifty thing. So your array vendor need only develop a single VASA provider to manage a whole storage system. So like I said, it's very cool because from a customer or an end user perspective, all you need to do is a software upgrade. Okay, follow the process and voila, it is virtual volumes ready. And secondly, all you need is one single plugin or software that is managing every array that you have underneath it. So today, if you have a farm of 10, 20 arrays, you plug in this one single VASA provider and all of it can be managed through that. Okay? I don't need to reiterate that. Every array which needs to provide virtual volumes has to support these APIs in order for it to talk virtual volumes. Okay? And now, finally, the final piece is how do you have this VASA provider? Like I said, there are very cool things that the array vendors are doing. There is one particular vendor who actually embed it into the firmware. So when you get the box, it's already there for you. So it's automatically, when you purchase it, it is automatically vVol enabled. But there are vendors who are also giving it as a firmware upgrade. There are vendors there who are asking you to run it as a plugin on their management console. But either ways, it's all going to be pretty easy. Okay? So, so just to reiterate, this is a very essential piece for us to build the story of virtual volumes. So what did we just learn? We said that we will bypass the file system. Okay? We'll use these special set of APIs, okay, VASA or VASA APIs, to communicate to the array. And through those APIs, we are having them create these individual VM files, which are virtual volumes. Okay? Now, that's exactly what we are trying to say. So now this VASA provider gets into this business of creating virtual volumes, and it opens up a door of possibilities actually, because all along virtual volumes has been VMDKs have been a prerogative of vSphere. We know which VMs have which VMDKs, and we know where they are being provisioned in which LUN. But now what we are doing is we are bypassing that entire paradigm you have been used to in the past few years. Instead, we are saying, now, Mr. Array Vendor, you can have this information as well. And now that opens up this possibilities that is quite multiple fold, actually. Because the array is aware of these individual objects, they can now do direct services on these objects. And that is key. That is exactly where you're going to see the benefit. Right? So when, just to quickly mention the benefit, instead of doing backup or replicating a LUN, because of this fine granularity at the array level, it amounts or it translates to backing up or replicating an individual object. Because of that, you're going to see so much efficient storage. You're going to see extreme performance. What takes hours and days for you to replicate, it's going to happen in a matter of few minutes. Okay? So VASA provider is the key to be talking between the ESX and the array. All right? So with that, let's talk about the data path. Okay? So this is also very important to understand why we need protocol endpoints. This is probably the most asked question. What is this? It is very hard for many people to grasp this notion of protocol endpoint. To understand that, let's compare today's world. What does a LUN do? It serves two purposes, right? It does two things. It is used as a container to store your VMDKs. That's where your VMDKs reside today. But what else does the LUN do? That is also your access point, right? So when you have a mount point or an IP address or a file path in case of NFS, that is exactly where ESX is sending I/O to the underlying array. So today, the LUN does two things, which is acting as an access point and also acting as your storage itself, where it stores the individual files. Now, one of the things that the engineering team did was pretty cool. They said that why should we have these two in the same entity? Why does LUN need to be the access point and also be the storage? There is no need. Because of that, it introduces several issues, right? If you're with me so far, you already know why that is a problem. The LUN has a limit. So every time you reach the limit, you create another LUN with its own access point. Another LUN, its own access point. So you end up creating smaller LUNs, okay? It is not flexible. It is fixed to one size. And then you end up having multiple access points. So their problems become intertwined. So the architects team said, how about we separate these two? Because you don't need that many access points. All you need is that many storage containers itself. You just want a flexible container. You want to be able to build a particular container, expand it, shrink it, all accessing through a single access point even. What would happen if we were able to do that? Scale. That's exactly what we are trying to achieve here. You're going to scale the storage in so many dimensions and no longer bound to the size limit. And also one other thing, what about the number of LUNs that are connected to a host? Today it is 256. Why? Because the access point was connected to the storage. You could have only 256 LUNs, so for a single host, you can have only 256 connections. Now you separate these two, guess what happens? Two things happen. You're no longer bound by that rigid number of connections, meaning you don't need 256 connections. There is no way that you will ever reach 256 connections in a short time, right? But at the same time, you can keep scaling the storage. It's actually quite brilliant if you think about it, right? With just a single change of separating the access point with the storage, you kill two birds with the same stone. You address the LUN size limit and the number of LUNs you can connect to a host. And that's exactly why this protocol endpoint is for. You're separating the access point from the storage. So now this protocol endpoint, right, it serves only one single purpose, which is to handle I/O from the ESX to the array. Now you can have a single access point talking to an array, right? Within the array, you can have as much storage as you can. And we are going to talk a little bit about that container as well, okay? So hopefully with this, you can understand why you need protocol endpoint and how it is addressing the current issues, all right? Now a few configuration points. What is this protocol endpoint, right? So now here comes the storage administrator. Today, what does the admin do? They create the LUN, right? And then they connect it to a host, right? They give the LUN to the vSphere admin, who then keeps track of which VMs goes into which LUN. Now this PE, since it's going to replace that I/O aspect of a LUN, it is only makes sense for the storage admin to manage it. So that's exactly what the storage admins out here are going to be doing. You are going to learn how to create a PE. It is part of the physical storage. So the first thing that you do when you get a new shiny box that says VWall enabled, you're going to go into the command prompt and say create PE, okay? So once you do that, what happens next? That's exactly what we are going to see in this slide. Now, some of the things to note, we'll talk about this aspect in the second half of this, but let's talk about what happens when you set a PE. So when you say create a PE, now this is exactly where all your different protocols comes into picture. I have spent a lot of meetings and a lot of time talking to customers who say, Do I need a block array or a file array? Do I need iSCSI, fiber channel, FCOE? And we have spent a lot of decision cycles determining that. We have spent a lot of skill set involved, brought our directors and architects in determining which ones to buy. Guess what happens with the protocol endpoint? This talks every protocol that's out there, okay? It can be a SCSI PE, it can be an NFS PE, fiber, whatever the case may be. But now, combined with what we saw earlier, what did we see? We saw a VASA provider and we said that we are going to offload the VM decays to the array. That logic, combined with this protocol endpoint, does something really cool, which is leveling the playing field between the protocols. So no longer you need to spend any time wondering whether you need block versus file. Everybody is going to talk fine granular. A PE can support any kind of protocols. So now that whole mystery is taken out of this entire picture. So all you need to worry about is getting an array that is virtual volumes enabled, right? So we'll see a lot of adoption quickly as soon as GA. Okay? One other thing about protocol endpoint is the multipathing policies, and I just had a TAM customer central, and they asked a really cool question there. They asked about zoning. So when you're talking about zoning, they're talking about multipathing policies. How is that applied today? You're applying it on the LUNS, right? You would take a few LUNS, you would zone it off. You'll apply any of the multipathing policies onto the LUN. What did we do with protocol endpoint? We said that those policies and everything need only be applied to the access mount point. And that's exactly what the PE is replacing. So guess where your multipathing policies and all your zoning policies go? Onto the PE. So it is the way, as we build the story, you will see how we match your existing storage paradigm with something new, but by removing all the restrictions and all the limits. But if you are concerned about multipathing policies, which works here, it will work exactly the same way on the PE, on a VWall array, okay? Same way with zoning. Zoning needs it that you can spend an hour just talking about protocol endpoint and zoning. So just keep in mind that when you say zoning, you can say that you take a PE and you can determine or you can decide which PEs gets exposed to the host, and that's exactly how the zoning works. If you have more questions on PEs, we can address it in the Q&A session, okay? So we talked about why you need a protocol endpoint, what is it, what does it do, and then we talked about who sets it up, and what the storage admin needs to do when they set it up, and how it levels the playing field among all the different protocols, right? So the final piece to all this is, okay, you have done all this work, you have created the PE, now what? Okay? So that's where the discovery process happens. Excuse me. So here we have something called as the entire discovery process that is very simple. Every few minutes or whatever the case may be, ESX does a scan. It does a rescan and a scan of the entire cluster. When we do that scan, we discover the PE. When we discover the PE, that's how ESX knows that the underlying array is a VWall enabled array. Okay? And what ESX does is it actually discovers PEs as they are added to the host. So if you have an existing, it's a brownfield deployment, you have a bunch of arrays that are now VWall speaking, you create a protocol endpoint, the next rescan will discover the PE and creates a database with all the existing PEs. All right? So this is protocol endpoint to a certain level of depth. Like I said, you can spend hours talking about protocol endpoint. But the key takeaway for you is understand why you need it. That is so important. And what is it replacing with the current world? What does it do? Who does it? And how ESX actually identifies that it is a new virtual volume PE and not an old legacy system. All right? So that's the data path for you guys. Now, with that, let's go talk about the storage capacity itself. So I'm sure the story is still very fuzzy in your heads. We talked about VASA Provider. We said that all of a sudden we no longer need file system that has been there for 30 years. Instead, you're going to use some out-of-band APIs and have the VMDKs be created by the VASA Provider on the array. Now, you must be wondering, what do I, as a storage admin, need to do to manage capacity? Again, going to the current world, what do? You are talking about LUNS, you're always talking about LUNS, and you're always provisioning LUNS. Now, with this, all of a sudden there's no more LUNS, but you have these hundreds of thousands of objects lying on your array. Do we expect you to manage each individual object? Obviously not. There could be an array vendor who supports hundreds of these objects. There could be an array vendor that supports millions of these objects. We definitely don't want you spending time managing these individual objects. And that's exactly where managing storage capacity in the virtual volumes world comes into play. Okay? So, we are going to introduce the concept of a container, and if you are with me so far, you already know what this is. We set the stage by saying, what does the LUN do? It does two things, and then we separated it out. We separated the access point and called it the protocol endpoint, but what we didn't talk so far is who is actually going to be the container to store the individual objects. You cannot just place it on the hardware array and manage these objects. So somebody has to do that second job of the LUN, and that's exactly what a storage container is. So you can see how we are separating those two concepts, but we are retaining the intent of it, right? So this container here actually will just do the second half of the LUN's job, which is to store the objects. And we know where the objects are, right? It's going to be on the array created by the array. So it's pretty cool that once we have this, it's very easy to deduce from this who is going to create the container. Who's going to create the container? The storage admin, exactly. So the admin is also going to create the container, and we are going to see how the storage admin's job changes ever so slightly with virtual volumes. Today it is a blind creation, deletion, management of LUNs. Tomorrow it's going to be very intelligent. If there are storage admins out there, we want you to think for your business. We want you to understand what your environment needs so that you can be creative on creating these containers. And we'll see how in the storage policy-based management portion. So this one is very straightforward, folks. It is going to store the VMDKs. However, it does not have any of the limitations of a LUN. There is no explicit maximum limit for a container. You can have a single terabyte container. You can have 10 terabytes of container. You can start with a terabyte, keep adding to it. You can start with 10 terabytes. You can shrink. It's all left entirely up to you. The only restriction is the maximum capacity of the array itself, and even that, if you're supporting, if you could do thin provision on that as well. Okay, so one thing to understand here is we have separated out the container concept, but we did not bring the hardware limit along with it. So one limit, if at all there is any with the storage container, is that a single container cannot cover or cannot go across arrays, at least in the first version. So you got to have a single container that is particular to that array. Okay. One other item is how many number of containers is what you guys have been asking the past 2 days. We don't have any limit on that as well. It is completely dictated by the array vendor. Okay. They are probably going to have several containers on an array, so you can siphon off every container based on whatever tiering or whatever capabilities they want to give to the end user. Okay, and then the last point is a container can be accessed through a protocol endpoint, and this is exactly where the confusion for some of you starts. So you have to remember throughout this virtual volumes session is the PE and the container remains separate. There is no dependency between those two. That's exactly what we want to do, right? We want to separate those two. So the way we are going to do the discovery process will also make it very clear, which is exactly what we are going to see here. So we saw with protocol endpoint, the discovery process is bottom to top. The VASA provider, excuse me, the VASA provider actually sends the PE information to the ESX, right? Actually, the ESX, I'm saying it wrong. What I meant is ESX actually discovers the protocol endpoint in a scan. What this storage container is going to do is different things. So the first thing is the storage admin sets up the container. They are going to slap in some capabilities for each of these containers, and hang on to the thought. We are going to double click on that in the later slides, and Rawlinson is going to elaborate on that. Once this is done, this is bottoms up. So the VASA provider actually discovers the container and reports it to the vCenter. So where in the PE case, the discovery process is top down, where the ESX scans and discovers the PE and maintains a database. In the case of a container, it's bottoms up. Okay? Now, this is where a few of these pieces are going to come together. So when you create a VM, so the vSphere admin comes in, okay? The storage admin has already created the protocol endpoint. Storage admin has already created the container. Now it's the job of the vSphere admin to start creating VMs. When the vSphere admin creates VMs, guess where it goes? It goes into these containers, because we had separated them out, right? This is for storing the individual objects. So that's exactly where those virtual volumes will reside. But then we also previously saw that the protocol endpoint is going to be the access point. So what does that protocol endpoint will be used for? Sending IOs. Okay? So now we introduced these two. We need to be very clear on the differences between the container and the LUN. So this was specifically, we didn't have any intention of actually having a separate slide for it, but then we got so many questions around this, we thought it's good enough to add one. So by now you should already know this. I would just have to repeat what's on the slide. Basically, differences are the differences are quite many. The size. That's the first thing that should come into your mind. There is a LUN maximum size. You don't necessarily have a maximum size limit on the containers. It can expand, shrink, whatever you want to do with it. Now, this particular piece here, where I've said heterogeneous capabilities, whereas homogeneous capabilities, that is exactly where you're going to start seeing a lot of differences. Today, with the LUN, you would put in all the VMs and the VM decays inside it. But if you want to say just clone a VM, right? What do you end up doing? Cloning the entire LUN, even though you do not want to clone the rest of the VMs in that LUN. That is going to change with the containers. This is where the storage admin's creativity comes into picture, and this is exactly where I meant that the admin needs to understand the business. Let's say you have a data center where you're using a lot of snapshots, okay? Now, your snapshots could be different RPU and RTU. You could snapshot every hour, you could snapshot a few days, few months, and your retention policies could be varied as well. You could retain it for a few hours, retain it for a few days. Now, what this container does is you can create different containers with different capabilities, so that if you have, say, 10 VMs that needs to be snapshotted, say, every 6th day, all of them can be provisioned into one container, okay? You can also have a different set of VMs with different set of RPOs in that container, But since you have fine granular exposure, you can specifically do those operations on those individual objects. And you're going to see how that is established through the storage policy-based management. Okay? So the differences between a container and a LUN are basically in how they handle and expose the per VM capability and the policies, and also in how the limits are being expressed today. Okay? And this is one question that always comes into mind. So what have we seen so far? We saw that we wanted to separate out the attributes of a LUN. We created the access point. We created the container to store the VMDKs. However, what do you use today? Data stores. That's what you do in a vSphere environment. If you're using DRS, if you're using SDRS, what do those entities do? They work on the data stores. Could you hold on the question for that? Okay. So in this case, now the question is, do I need to create data stores? Okay? You do. However, the difference is they are one and the same. We do not need to have any other differentiation between the data store and the container. But why are we slapping the pseudo name around the container called the data store? It's nothing but to facilitate all these individual features, vSphere features that work. For example, HA. Many of you use HA. How does HA work today? It works on the data stores. Do we want the HA to continue to work as is? Give them the concept of a data store, but which is nothing but a container, and your HA is going to work smoothly on a vVol environment as well. VCAC, many of you use VCAC. Guess what? Data stores again, right? And not just that, I mentioned already SDRS, DRS, HA, FT, everything works on a data store level. We didn't want to approve the entire vSphere suite to go and change it for a per VM or an object level operation, and it's not needed even. So for those purposes, we retained that concept of the data store, and that's exactly what you're going to see as well. Okay? So this is just to give you an idea. I'm not a big fan of showing screenshots, but since I've been talking quite a bit, this seems to be a nice place to give you guys an idea of what you can expect, especially if you're going to take hands-on lab, which I highly recommend you take it. This is something that you're going to start seeing. For example, look at this here. You're actually creating a container, but it is not a data store, but it's nothing but a container underneath. Okay? All right. So this is also one slide that I wanted to include. What do you guys actually see? It's all one and the same, right? So the storage admin will see the container, okay? But the vSphere admin will see the data store. They are one and the same. But what I mean is if you're using vCenter UI, web client, what you're going to see is this data store called the vVol data store. But you as a storage admin, when you're actually playing around on your array, you will see the container. You will be creating the containers. Okay? So there's a lot of concepts to grasp. All right, but I swear that was the last of any new paradigms that we are introducing. All right, so what we are going to do is shift gears a little bit here and talk about policies. And it looks like I have really gone over my limits. So I'm going to hand it over to Rawlinson, who's going to talk about policies and then tie it all back together.
Thank you, Susie, after my awesome introduction. Take that. All right, so one of the things that I like to kind of focus and talk about a lot is service levels, right? You guys may have heard or seen this other product called Virtual SAN that we sort of kind of talked about a little bit, which we started driving this model, this policy-driven model and framework. So what we're doing with virtual volumes is it's something that, in the same concept, but we're now enabling much more richer capabilities, because now instead of us defining what you can use, this is going to come directly from your arrays. So whatever capability you have within your arrays, regardless of what it is, as long as they're vVol compliant and capable, you will now be able to leverage that on a per VMDK or object basis, depending on how we look at it. So when we talk about, obviously, SPBM, we all know that's our Storage Policy-Based Management Framework, which is something that lives and exists within the vSphere framework, right? It's part of the system. So as Susie was stating before, we look at some of these containers, and as we try to create and talk about what these storage containers are, why would we have multiple? Why don't we just have one? Policies is specifically one of those that makes it another reason why to do that. Because as you probably saw in the previous illustration, you can enable different capabilities and different things that you can do per that grouping of those storage containers. When it comes to what you have available, we're talking about, obviously now at this point, publishing these capabilities, but we're not the ones running them, right? These are coming from the storage admin. They're coming from your arrays. So these capabilities that you bought into for these particular systems, they're still there. You will still be able to leverage them as long as you have now go through that firmware upgrade, go through the process to get to that point. But the whole thing here is that through the VASA APIs, which are not new, you guys are aware of VASA APIs. The only thing that's new now is that we have VASA 2.0, right? And that's to address this new capabilities and all the things we have with virtual volumes. As we continue to kind of go through the configuration and setting up some of these capabilities, you probably are now accustomed to some of the things that are done on your arrays. You've seen in the past that you can arrange either replication, snapshotting capabilities, all different types of policies that are available. Now, we talk about some of these in a very high level, which are some of the most common policies and some of the most common capabilities that you find today in arrays. But realistically speaking, you'll find some of these new implementations, these new systems, which can prevent richer capabilities, ranging from QoS, from IOPS, and all these kind of things that will be available. And these are the kind of things that you will still be able to leverage, but addressing it in this type of model now, right? So when we talk about, for example, looking at being able to define a default policy, a default capability, you can do that, right? You can manage these objects, these containers, so that you can provide these type of data services. And like Susie said, they're not static. If at some point in time these things need to expand, they need to grow, you need to add a new capability, as long as it's there and you expose it to it, you have it. But the deal now is that you'll be able to address this on a per vVol basis, on a per VMDK basis, which is it's great, and it's granular. Kind of granular capability makes a big difference. Here's an example of one of our sort of like a sample implementation, what you would see in as a VMworld provider. So this example, if you go to the HOL and you take the labs that we have created for virtual volumes, you'll see that the VMware one looks like this. These are some capabilities that we have available. If you take the pure storage one, you'll see different capabilities. If you see something like the NetApp implementation or whichever the vendors are out there, you'll see that they have different capabilities that are specifically exposed based on what they can do. Now, your different arrays can expose the capabilities and provide whatever you need on a per VMDK basis, but it's a volume, okay? When it comes to how do we maintain that within the system, one of the big things that we have, and one of the most, I think, from an administrative standpoint, one of the most valuable things we have in that policy framework is the compliancy check factor, right? So when you have a sort of an application deployed based on a specific service level that you need to meet, we want to make sure that from within the platform itself, we want to be able to identify whether or not that container is able to satisfy those requirements on that virtual machine, on that object, right? And when we talk about virtual machine, you can actually apply the same policy that you may create on the entire virtual machine, but you can also individually create a policy and assign it to them and apply them as well, right? So each one of them has different capabilities, so now you can take advantage of using some of these capabilities in a smarter way. One example of that could be maybe you don't have to snapshot your OS volume or your OS VMDK as much as you snapshot the data, right? Now you have the ability of dictating that on a per object level, which is a great use case and a great example of doing that. And as we just, we'll continue to expand on that. In the UI, you'll be able to see this policy. You've seen that with some of the things we're doing. This is part of the core framework now. So it's not like we're showing you something you've never seen before, and we will continue to use this and enforce this so that you can actually see how we can consistently maintain compliance. And when things are not in compliance, you can obviously see that way we'll give you a red X. So we talk about virtual volumes. We talk about all the concepts, right? I can tell you that the one thing that I've gotten from most people has been that when we talk about virtual volumes, they thought it was a new LUN, right? It was a concept of this container, and I've had several conversations with folks about this, and that was the somewhat assumption, right? A virtual volume, as Susie said before, is the VMDK in all of its constituents, right? The other components that are part of a virtual machine, which are now placed into an object model, and is a virtual volume. It's recognized as what we call a virtual volume or a VVol, which you'll see in the different implementations. So we have a couple of those virtual volumes, right? How many of you are familiar with virtual SAN? Raise your hand. Not enough. So within that product, well, we also have the concept of these types of things that are recognized as objects, and they play a specific thing and they play a specific role. So here particularly, you can see the definition of what these different volumes are, right? And I'm going to show you a screenshot on what you see, something better than what you see on the left or right-hand side, whichever you're looking at it. So each one of them are defined differently. Obviously, the data VVol is the VMDK. When we talk about the config VVol, which is the one that I think most folks will probably pay attention to in some cases, because when you look at a virtual machine, as you see up there, right, you see all these different files, all these different virtual machine files that exist when you're looking at a virtual machine from the vSphere level, right? But when you look at the array, it looks a little different, right? And they come up as the form as that config VVol. We have a mem VVol, which basically manages the snapshots. We'll have a swap VVol, which only gets created when it comes to when the virtual machines are turned on. And then we have other, right, which is basically a vendor-specific implementation, which could be many things. Something that's unique to the vendor comes up as a type of volume, and you'll see it there. Overall, it's the same concept we sort of introduced in the past, but similar to what Susie showed before, when you look at the workflow, right, we're always concerned about what we see, what we don't see, what's mine, what's yours, right? So it's really good to understand and become familiar with what each one of these admins, each one of these management institutions will see when they work with virtual volumes. So when you look at from a vSphere perspective, obviously the first step is obviously the storage admin will create the container, will configure the PEs, and all that stuff is done at that layer. The vSphere admin at that point maps that container to a LUN because to a data store because that's what we do. We map data stores because our system understands data stores. But when you look inside of it, right, after you look dealing with your policies, you're going to see that at a storage level, right, you will see VVols. There's no more VMFS down here. We're talking about having volumes individually placed in these containers. But if you go to the vSphere view, you're going to see the good old same VMDKs that we always have, right? Things that we have with VMs. Everything that applies to a virtual machine now that are enhanced with the use of policies. Here's what that would look like in an environment where, keep in mind that the black screen is an implementation from us to simulate what it looks like in an array system. This view will look totally different, always depending on what you're using, what type of array you would have. But if you can clearly identify how we can still within vSphere see the same components that are part of a virtual machine, right? We talk about virtual machine as a bunch of set of files. It's just that in two different implementations of our storage products, they become objects, right? In virtual volumes, they're VVols, but they're exactly the same when you look at the other. You see how they map to one another, right? A storage admin will see that. A vSphere admin will continue to see the same things we see because it's basically what we manage and what we understand in the system. So when we talk about the binding request, what's the operation that allows us to access each individual VVol, right? So there's a binding operation. This binding operation is what allows the actual IO path to then establish that communication through the VASA bind request. So if I need to access a specific action on a VVol, let's say, for example, you need to start either cloning or doing some type of operation, there will be a bind operation that exists that happens so that I can access that particular VVol at that point in time, right? When it comes to the VASA provider, there are two things when it comes to receiving and sending a bind request. So for one, it returns the PE ID, which is a protocol endpoint you learned from Susie before. That ID then is bound to a specific volume, to a specific VVol, right? At that point in time, there's a unique secondary request ID that basically comes up from the PE, which is assigned to sustain that communication and maintain it whenever it's active, right? And that's how it remains bound. Overall, when it comes to dealing with SCSI, obviously there's a secondary ID that comes up to identify that. For NAS-specific PEs, when it comes to that point, the ID is based on the file path. So for us, when we deal with mount points, you'll see that with the different implementations that may exist, you may have that sort of path access based on a different IP, a different ID, a different interface, but that's basically how that works, right? So it's basically, you can actually see that within the UI. The whole point is that it's a many-to-many relationship when it comes between the vVols and the PEs, and that can go throughout the entire environment in many ways. Okay. So, talk about data services. Data services are now there's a couple of things that we can have available. So we can have, for example, we talk about snapshots being one of the data services. There's a couple of things here that happen when we deal with snapshots. There are some common capabilities that exist within our platform that you already use. For example, you might be used to using snapshots that are created based on our UI through the virtual machines. But there's also the concept of snapshotting at the array. So you have a managed array and what we identified as a non-managed array snapshot against a non-managed snapshot in this case. Overall, it's a copy and write image in terms of the virtual volume. Those two separate types basically tell you how many, what's the maximum specifically supported by ESX, so we have that defined on a base by 32, but when it comes to an unmanaged type of snapshot, that's obviously not falling back into the array's capabilities, right? So we obviously being able to leverage that, and it'll be based on however many snapshots the array can actually manage, which then you have that control, that sort of level of granularity still, but if you still want to manage and do things where you utilize the vSphere infrastructure for snapshot management and all those kind of things, those are the ones that you find specifically bound to a specific virtual machine, and you can traverse between them, right? The operation of going through the unmanaged snapshot might be totally different in this case, and again, it's based on the array. Piecing it all together, I think I'm going to pass it back to Susie. Things you want to hear?
Yeah. Thank you, Rawlinson. So it's a lot of concepts you saw throughout the session, and a lot to grasp, a lot to understand, and eventually leave you guys with wondering how this is going to fit into your data center. If your questions are not answered, it's quite all right. There's always ways to get hold of us to continue the discussion. I just want to quickly send you guys off with some, we're not done yet. There's still a partner who's going to come.
The t-shirts are coming at the end.
So we talked a lot about new concepts. We talked about protocol endpoints, which is just separating the access point from the LUN and creating a new entity. We talked about containers. We talked about VASA Provider. And slowly we pieced it all together. We said that discovery process will announce to the ESX the underlying virtual volumes concepts. And we also said that to communicate to or send IOs to the virtual volumes, all the binding requests happen, and we put it all together and gave you one Mushida virtual volume array. Okay? So what we are going to talk a little bit about is making the transition to virtual volumes. It's going to be a very easy transition, hopefully. But one thing that we are talking about is this is where I get to say kudos to all the array vendors. Trust me, they have been through so much pain with us over years of development, and I do want to take this opportunity to also apologize to them that it has taken us this long to develop virtual volumes. I myself have been up on the stage 3 years in a row talking about virtual volumes, and they have done a tremendous job of coming up with supporting virtual volumes in every array. And the story they have to say is amazing. Each one of them have such a unique story. Okay, we have a huge ecosystem working on virtual volumes. 3 of them actually have press releases, and it's pretty cool. NetApp, HP, and Dell went out with their press release. If they have not done already, they will be in the next few days. And of course, virtual volumes is in beta. Okay, with this huge broad ecosystem support, we believe that almost any array in any of your data center will support virtual volumes. Okay. The other aspect for which I'm going to need Rawlinson to talk a little bit about is this is a segue to bringing the array vendor onto the stage. We have vMotion, guys. So
oops, I thought I was done. So questions have come up, right? So how do I get to, I have an array that I have existing VMFS volumes. I now have vVol capable. So the default operation, whenever you have an array that's even supports a VAAI or vVols, right? Whenever there's a vVol operation, the default is to always use the vVol primitives. In the event, for example, here, when you have implementations where some of those things, they might, because of there may be an implementation limitation or something like that, if the VMworld API or the VMworld primitives are used and not worked, we will default back to sort of like the ones that are available within the platform and are supported. Now, there are different scenarios that you can actually explore here, whether what happens when you go from a VVol to another VVol capable container, and those different things happen differently depending on how the implementation is done, whether you're going to go across a different array, for example, or you're going to stay within the array. So there's some information that we actually have published on that, those particular scenarios. This one just to kind of to get folks started with the whole implementation. How do I go from my normal infrastructure to the now new virtual volumes containers?
Yeah, so with this, I actually want to invite our esteemed partner, Pure Storage, onto the stage, and they are going to give you a good overview and a demo of what they have done. And can you miss their orange t-shirt or what? And look at that, he's even matched it with the corresponding.
Well, I'm actually going to have to skip the demo because we're about 4 minutes here, but I'm just going to go over a couple slides. We will have the demo in the booth. I'm presenting tomorrow, and I'll be showing a demo. And originally, Von Stewart was supposed to be here, but he's getting his hair done for his session at 5, and he's also doing the demo then. So, you know, there's plenty of time to see it. But I'll just talk about a little bit what we have to add to VVols and what's going on. So, I mean, the Pure Storage is an all-flash array, right? So some of the things that we offer, right? Data reduction. Obviously, the performance of flash, the availability, the operational recovery that comes along with that, and disaster recovery. Right? We have built-in replication, things like that. So the initial release of VVols, we'll be using our built-in replication to add on to what VVols can do. And then when VVols comes out with more versions later, where they have the built-in replication within the VVol APIs, we'll be leveraging that as well. But initially, we'll offer the normal things that we have on the array to add on to what VVols has in the initial release. So, you know, today we have asynchronous replication on the array. So you'll be able to replicate on a VM or a virtual disk level using our internally built-in replication. Tomorrow with VVols, as I said, there'll be that built-in in-context replication that you can do from the vSphere web client and things like that. So we'll be able to build on with the replication, and then when the next version comes out, we'll be able to support that as well. So, the important thing here is to realize that adding VVols to existing LUNs is storage objects within the flash array, right? So today objects are virtual LUNs on our array. They're virtual LUNs as it is. So there's really nothing we need to change to how we do storage on the flash array. Everything is just basically an object. How it's accessed is slightly different, but how you'll see it on the array is no different. We can still manage it, we can still recover it, we can still duplicate it just as you have with normal volumes. And one of the great things that comes along with this is how we'll be able to add on with data reduction levels on your per VMDK. So service providers, right, they need this information on the virtual disk level to be able to say, hey, this virtual disk is getting this data reduction, this virtual disk is having this type of performance level, the IOPS levels like that. So it's a very important thing for people to need to charge back or maybe to further increase the efficiency of environment by seeing that down at that level. So one of also the great things about Pure Storage Flash Array is that everything is non-disruptive, right? So we can non-disruptively upgrade from our 405 system. We can non-disruptively our hardware up to the 420 or the 450, right? So if you have the smallest system and you want a better one, we can actually we can change the hardware to the better one without any performance impact or any loss or any disruption in your I/O, right? And then we'll also be able to do that with your VVol migration pattern, which dovetails into what they were talking about earlier. So when VVols comes out, we'll support it when VVol is released officially by VMware. You'll be able to upgrade your code non-disruptively, and you'll be able to use things like storage vMotion to move your VMFS virtual machines right into VVols. And the cool thing about how we do storage is that it's all metadata, right? So the data is stored, and we just have metadata pointers to the unique parts on the array. So when you do a storage vMotion, typically on some traditional arrays, you need additional capacity swing space to move it from point A to point B to the new VVol, something like that. But in this case, you don't need additional capacity. All you have to do is do a storage vMotion, and we'll just move those metadata pointers from one place to another, and nothing else changes, right? You're now moving on vVols, doing a storage vMotion. There's no, you don't need to add additional hardware. You don't need to move off the array. You don't need a new array. It'll be a non-disruptive code upgrade to vVols, and you can move right into it. So it's a very, very easy migration pattern. So if you have any more questions about, I mean, I blew through these slides. I didn't want to keep you much any longer, but if you have any more questions, come visit us at the booth, please. I have a session tomorrow. We'll be talking about this some more, and as well as Vaughn has one at 5. So thanks a lot. I appreciate it.
I do apologize for running through, and I was warned by my colleague at Pure Storage that I have one too many slides. So for the repeat session tomorrow, we'll cut down some of these slides. So for questions, I will entertain a couple of questions, and then we can move it outside, and I'll be more than glad to answer questions. Any questions?
I have one.
Yeah.
So, a couple questions. One on the
I am so sorry, I can't hear your question.
microphone. Okay.
Sorry.
So, with the PE, one thing for clarification, is a PE assigned per cluster or is it per array?
Yeah, so I'm going to answer that, but what I would do is I would ask Derek to answer that question. Derek, can you answer that question? Yeah. So Derek is the engineering tech lead and architect for virtual volumes. So the question is, do you assign the PE to a cluster?
No, you use a protocol endpoint based on a storage container association.
Louder.
Storage container association. It's not per cluster. Protocol endpoint or multiple protocol endpoints are associated with an actual storage container. It's kind of a host-based property as opposed to a cluster-wide.
So wait a minute. So you're saying that, before we were, you would assign a LUN and it would be masked and
Yes.
zoned to a series of hosts. The protocol endpoint is supposed to take over for that. So for whatever grouping of hosts that need to see storage containers, they're going to have a protocol endpoint. But would that be for anything on the array? So like one protocol endpoint could theoretically be available for as many ESX hosts as you
Oh,
have.
thank you. Thank you. Thank
Okay.
you. Yeah.
Is storage vMotion going to be as a migration strategy to vVols?
Yes, absolutely. In fact, that is going to be your migration story, both vMotion and storage vMotion.
Okay. Thank you.
Sure.
For raw device mappings, today, if you're trying to do physical to virtual clustering, you have to still do RDMs. Is there going to be a way using vVols to maybe instantiate a LUN version of a virtual volume so that it can be shared with the physical host? Or would you have to fall back to legacy mechanisms, go to the storage array, create the RDM, and then present it as a normal LUN in a parallel fashion to vVols?
I'm going to have to defer that to Derek.
So I guess, can you bridge from virtual to physical with containers?
It's kind of orthogonal to the point of
Yeah.
virtual volumes. Sorry, I wasn't trying to headbutt here. So, it's, I mean, you could, but that's on the vendor to enable you to do that. There's nothing in the virtual volume APIs that allow you to do that specifically.
My question is storage DRS going away, and can we use vVols for view?
Two questions. Storage DRS is not going away. However, we do not support SDRs in the first version, but definitely we are trying to see how to orchestrate, or rather manage the data, vVol data stores through SDRs in the second version. Second question about view, absolutely. Okay. And in fact, here we are going to come up with a good interrupt story around GA timeframe.
Okay, thank you.
Sure.
So with regards to snapshots, non-array snapshots, is it a classic copy on write architecture? Do you see degradation as you do more snapshots with I/O performance?
That's kind of an implementation detail of the vendor itself. We impose no actual performance hindrance from an ESX perspective.
So I thought the copy on write was if the array vendor's not providing snapshot functionality?
No, the vendor needs to provide the snapshot functionality. That's mandatory in the API.
Just a quick question. So if you already have like NetApp or stuff running, is it just a firmware upgrade to get the VVOF capability? Or do you have to buy a new SAN to get the VVOF capability?
No, so actually it depends on the array vendor. Most of the array vendors are going to be supporting virtual volumes in your existing array, which is why I kept repeating the point that it is as simple as upgrading your firmware.
Okay.
So but there are vendors who do choose to support it only on their new array models. You'd have to talk to your vendor to figure out what they're doing. Okay?
Okay, I got a couple of DR questions. If you lose your virtual center, are you able to? Is it self-describing? Can you attach to a storage container and rediscover the virtual machines?
Yeah. So the way it works today is going to continue because it's not. That is exactly why we have the data store wrap around that container. Mm-hmm. So from a vCenter perspective, what works today will continue to work on a VMworld data store.
Okay, and is SRM going to be supported with?
Okay, not with the first version, but that is going to be our main focus for the following version. Okay?
Is there a way to discover vvols that are created through clones on the array side? Say, right now I want to have a LUN based on a point in time. I'll just create that on the array, and then I'll discover it on ESX.
Yeah.
So there is that in the interface?
Yes, because it's a virtual volume at the end of the day. The discovery process is only for the protocol endpoint and the container. What's in it, you've already discovered. So, and again, Rawlinson was talking about the bind. So when you have a bind operation, that's how you actually get to know of the virtual volumes inside the container.
And so vCenter's been extended to have that kind of an interface, because I don't think the arrays will. Oh, okay.
Yes, and that's why I showed that slide about the ecosystem. Yeah. All right.
So with the storage container, we talked about how you can have multiple storage containers to have different capabilities exposed, and then we also said that their size is only limited by the array.
Yeah.
So kind of thinking a couple things in my mind. So a lot of arrays might be used for physical servers as well, where they're going to obviously still use LUNs, which will take away space.
Yeah.
So would essentially, when we look at the data store, if there are multiple containers and therefore multiple containers, would each of them essentially reflect the capacity of the array regardless? So like if a LUN was provisioned to a physical server, that would decrement the available space. If something was placed in one storage container, both data store representations would show a decrement in space? And then I guess maybe the follow-up to that is, could the storage vendor or the storage admin say, well, you know what, I need to make sure that I have some amount of space for my physical servers, therefore the storage containers are limited to some extent? No,
but that is yes, to the second question, but that is entirely limited to what your administrator is going to dictate for the container. It is not a limit that is dictated by ESX. That's the huge difference there, right? Okay. It's not, the limit is what you provide rather than what the hardware dictates.
Okay. So that makes sense. So what you're saying is the storage admin could choose to limit a storage container?
Yes, yes. Okay. Unfortunately, we have to transfer this outside. Okay.
Let me make one last clarification on the previous question about lost vvols. What you can see is all the config vvols in a storage container. You can't necessarily see every single vvol. So if a data vvol is cloned or something, you won't see that. All you'll see is the config vvols that exist. So regardless of the state of VC, you'll be able to browse all the config vvols in a pseudo file system. We can follow up outside if you want.